We are going to start now the next lecture, lecture 5 of chapter 2, class 11th mathematics, relations and functions. So in this lecture we will talk about some piecewise functions. So piecewise function means we are talking about, suppose a function is given, we are saying fx is equal to, say it is 2 and 3, it is taking two values, and this is when say 0 is less than equal to x is less than 1, and this is 1 is less than x is less than equal to 2. So what this function represents is, we are saying when the value of the domain of this function we are talking about, it is, the domain means what values of x it can take. It can take these values. So we are saying domain of f that is equal to the closed interval 0 to 2. It can take any value between 0 and 2. We are saying if it is taking the value from 0 to 1, I think it is taking the value 0 to 1, that is if x belongs to 0 to 1, then the value of fx is equal to 2. And if the value of x it belongs to 1 to 2, we are saying fx is equal to 3. So we are talking about a machine over here. We are saying we are giving some value. Now this value, it is first we have to look where this x is lying. We are saying if x is lying between 0 and 1, the machine works like it gives the answer as 2. And if the value of x lies between 1 and 2, it is not equality sign over here. So we are saying the answer it is giving, it is 3. So these kind of functions that are divided like this, these kind of function, these are called piecewise function. That is, this is one piece of the function, this is second piece of the function. So we are going to see some examples of such piecewise functions. So first function we have over here, it is absolute value function. It is also called the modulus function. So it is defined, this is the definition of modulus function. It is mod of x, this is read as, this term we are saying, these two lines that we have drawn, this is read as mod of x, or it is modulus of x or absolute value of x. If we substitute some value of x over here, it will return the value in this form. So we are saying if x is greater than equal to 0, how this function is defined, we are saying if x is greater than equal to 0, then fx is equal to mod x is equal to x, it will return the value x. And if x is less than 0, then fx gives the value, that is mod x is equal to minus of x. So now suppose I have to calculate the value of f of minus 3. Where it is lying? It is lying in this portion, that is x is less than 0. So what is the answer we will get? It is minus of x. This minus sign, we are saying it is because of this formula. This minus sign, it is because of this formula, and we have to substitute the value of x. We are saying x is equal to minus 3. So minus 3 we put over here, and the answer we obtain, this minus and minus gets cancelled. The answer we obtain, it is 3. So what we can see from this is that this function mod x, it actually gives us the positive value of any number. If suppose a number x I am taking, it is 2, then mod of x is equal to, we are saying it is just mod of x is equal to x when x is greater than equal to 0. So the answer is 2. If I am substituting x is equal to minus 5, the value of mod x will become minus of minus 5, that is equal to pi. So if we plot the graph of these functions, this function we are talking about, so we are saying we have two parts over here. I am writing this function in this way, that if x is greater than equal to 0, we are saying fx is equal to x, and if x is less than 0, then fx is equal to minus of x. Now what is graph of fx is equal to x? If we have to plot the graph of fx is equal to x, it is this straight line. The region we are talking about, it is x is greater than equal to 0. This is the portion x is greater than equal to 0. Now when we are talking about this second portion over here, that is if x is greater than 0, we are saying fx is equal to minus of x. So graph of this, if you will plot the point, we are saying corresponding to minus 1, the point we have, it is 1, corresponding to minus 2, for x is equal to minus 2, we have the point 2. So we are saying for x is equal to minus 1, we have y is equal to 1, for x is equal to minus 2, we have y is equal to 2. So the graph of this line is in this form. We are saying for x is less than 0, for these terms we are talking about, for x is less than 0, fx is equal to minus x, it has graph in this form. So combining both these graphs, we obtain that the final graph we have, it is shown over here. These are the x-axis and y-axis. This is the line representing y is equal to x. This is the portion we are talking about. This portion we are talking about, this is x is greater than equal to 0, including this point 0. And we are saying for x is less than 0, we have y is equal to minus x. So this is the graph of y is equal to minus x. So final overall graph we obtain, it is in this form, that these are the two lines we are talking about. This is the graph of the function y is equal to mod x. So what we get from this value is that the answers we obtain over here, the answer we are obtaining over here, it is never negative. The values of y we obtain, they are negative. Now next we have listed some properties over here. So the first property we have, it is square root of x square is equal to mod x. So what this thing means is, if we are talking about the square root of 2 square, the answer we have, it is mod x. Mod of x means the value of x over here, it is 2. The answer we are obtaining, it is 2. And if we have square root of minus 2 square, the answer we are having, it is mod of minus 2, that is equal to 2. So this is our first property. This thing you should always remember, that whenever we are talking about the value of square root of x square, it is not x, but it is mod x. This thing will be more clear to you if we will look at the domain of this function. Look at this function x square over here. So what is domain of this function? Domain of this function is R. But if we are talking about square root of x, the domain of this function, it is 0 to infinity. These things we will discuss in our next slides. We are saying when we are talking about the function square root of x, we are saying the domain of this function, it is closed interval 0 to infinity. It cannot take negative values, because right now we are talking only about the real valued functions. If we will take the square root of minus 1, we are saying right now when we are talking about the function whose range or codomain is R, then fx is equal to this x cannot have the value minus 1. So we are saying the domain of this function square root x, it is closed interval 0 to infinity. But when we are talking about the function square root of x square, it has the domain of this function, it is real line. The answer we are obtaining, it is a real number. So we are saying that it can also take the negative value. So minus 2 is also possible, minus 3 is also possible. So how this function is defined is, it is square root of x square is equal to mod of x. Next property we have is, it is mod of x, that is equal to mod of minus x, that is equal to mod of x. So if we are saying, suppose x is greater than equal to 0, some x we are considering, then what is mod of x? This will give us the answer. What is mod x? When x is greater than equal to 0, it is x, and the answer we are obtaining, it is equal to mod of x. Now second case we are talking about, if x is less than 0, then mod of x, that is equal to mod of minus of x. And what is mod of minus of x? It is equal to mod x. We are saying mod of minus x, that is equal to mod x. This thing you can prove again by considering this thing, that x is less than 0. So it means this value will be positive. So the overall value we are getting, the overall answer we will obtain from this, if x is less than 0, the overall answer we will get it is equal to minus of x. So this is our second property that we should remember. It is mod of x that is equal to mod of minus x that is equal to mod of x. Next we have is mod of x. It is another kind of definition you can say, or this is just like a formula we are talking about. So mod of x is equal to maximum of minus x or x. So if we are talking about two cases again, x is greater than equal to 0 and if x is less than 0. We are saying when x is greater than equal to 0, say we are considering x is equal to 4. I am just giving an example over here. So what we have is that mod of 4 that is equal to maximum of minus 4 or 4, and maximum of these two values it is 4. Now if we are considering x is less than 0, say x is equal to minus 4 we are considering. So what is mod of minus 4? That is equal to maximum of, it is minus x, the value of x we have it is minus 4. So it is minus of minus 4 comma minus 4. Again the answer we obtain it is equal to 4. So we are saying that maximum of minus x comma x, that gives us the value as this mod x. It is giving us the positive value. Next, when we are talking about this case, it is minus of mod x is equal to minimum of these two. So again we are considering two terms, cases over here. X is greater than equal to 0 when x is less than 0. So we are saying when x is greater than equal to 0, suppose x is equal to 7. So what is minus mod of 7? That is equal to minimum of minus 7 comma 7. So what is minimum of these two values? It is minus 7, and it is clear that this value is equal to minus 7. Similarly, these are not the proofs we are talking about. Proofs are a bit different from these things. I am just giving you the examples that how these formulas can be applied. Next we are talking about this formula when x is less than 0. Suppose we are saying x is equal to minus 7. So it is minus sign over here and minus 7 over here. So what is this LHS value we are talking about? LHS value we have, it is minus of, what is mod of minus 7? It is minus this value we are talking about. What is mod of minus 7? It is equal to 7. And when we are saying what is RHS value over here, the RHS we have, it is minimum of minus x. Minus x means minus of minus 7 comma x, it is minus 7. So the answer we are getting, it is minimum of, this term will become 7 and this term will become minus 7. So answer we are getting, it is minus 7. So both LHS and RHS, they are equal. This is how we can apply these formulas. There are proofs also for this formula, but we are not discussing the proof over here, and you don't need proof at this stage. So these formula, these are sufficient for you at this moment. Next we have maximum of A and B. We have to calculate the value of maximum of A and B. Suppose I am talking about, I have to calculate the value of maximum of minus 3 and 2. So the value of A I am taking minus 3, value of B I am taking it is 2. So the formula we can apply, it is equal to minus 3 plus 2 by 2 plus minus 3 minus 2 by 2, and it is mod on this value. This value it contains modulus of this number. So the answer we obtain, that is equal to minus 1 by 2 plus, what is this value over here, is mod of minus 5 by 2. What is mod of minus 5 by 2? It is plus 5 by 2. So the answer we obtain for this, it is 4 by 2, and that is equal to 2. Now if we have to calculate the minimum of both these values, when we are calculating minimum of minus 3 and 2, the formula we are saying it is A plus B by 2 minus 3 plus 2 by 2 minus 3 minus 2 by 2, and again it is mod over here. So on solving this, we will get it is minus 1 by 2 minus this value we have, it is 5 by 2, that is equal to minus 6 by 2, that is equal to minus 3. So this is the formula for minimum of, this is the minimum value of minus 3. So we have two formulas over here, that if we have maximum of two numbers A, have A and B, we can write this in the terms of modulus of function. And when we are talking about minimum of A and B, we can write this mathematically in terms of the modulus function. Next formula we have is mod of x plus y is less than equal to mod x plus mod y. Now this thing gives us to better understanding of this formula, we should understand the mod as the length. We are saying we are considering this mod basically as the length. So if I am talking about mod of minus 3, so what I am saying is this is the point 0, this is minus 1, minus 2 and minus 3. So I am talking about length means I am talking about distance of 0 to the point minus 3. So we are saying length, or we are saying it is distance. When I am talking about mod x, it is distance from origin. So if we look at this formula, it is mod of x plus y is less than equal to mod x plus mod y. Suppose we are talking about two numbers x and y. This is the origin, this is x, and say this number it is y over here. So what we are saying is that distance of this point O from x, the distance of this point O from y, that is equal, is always greater than equal to the distance of this. This is not x plus y we are talking about. The number we obtain x plus y, it may be somewhere between over here. So we are saying, say this is the number we are talking about, it is x plus y. So we are saying this number, this distance will always less than equal to distance of x and distance of y. So we are writing it is in this form, that distance of x plus y is always less than equal to length, distance of x from the origin plus distance of y from the origin. Now in the next case we have is that the equality holds, this equality holds if x into y is greater than equal to 0. We can understand this situation from here. Suppose we are saying this is the origin, we are taking x into y is greater than equal to 0 means both x and y have same sign, both of these are same sign. So we are saying this is the point x, say this is the point y, both of these are positive. So there will be a number over here that is equal to x plus y. Now what we are saying is that distance of the region from x plus distance of the region from y, that is equal to the distance of region from x plus y. Suppose this number we are saying it is 3, this number we are 4, this number it is 7. So this distance we have it is 3, this distance we have it is 4, and this distance we will have it is 7. Similarly on the negative side we are saying, suppose this is minus 1, minus 2, and if we add both these values we will get it is minus 3. So this distance it is 1, this distance it is 2, and this distance we have it is 3. So again what we are getting is that 1 plus 2 is equal to 3. Next we are saying x minus y mod, that is equal to mod of x plus mod of y if and only if x into y is less than equal to 0. X into y is less than equal to 0 means x and y are of opposite sign. That is, if x is positive, y is negative. So how we can look at this condition over here? We are saying, suppose this is the origin, this is the point x. Suppose the value of x we have it is minus 2, and the value of y we have it is 3. So what we get is x into y is less than equal to 0. Now what is x minus y? We are writing this value, it is x is equal to minus 2, y is equal to 3. So the value of x minus y we have, that is equal to minus 2 minus 3, that is equal to minus 5. So there is a point over here, say this point is x is equal to minus 5. So what is the distance of this point O from X? The distance of this point O from X, it is 2 units. What is the distance of O from Y, origin to Y? This distance we are talking about, this is 5 units. And what is the distance of X minus Y from the origin? This distance we are talking about, this whole distance we are saying. This whole distance will be equal to, this distance is not 5, this is 3 units, and this distance we are talking about, this is 5 units. So what we are saying over here, that this 2 plus 3, that is equal to 5. So we are saying if X into Y is less than equal to 0, that is X and Y are of opposite signs, then we have mod of X minus Y is equal to mod of X plus mod of Y. Next we have is mod of X is less than equal to A. It is given that A is positive. So what this is representing as a region over here, we are saying we have, this is the region O. We are taking mod X as distance from the origin, and we are saying the distance of the region, all the points whose distance is less than equal to A. So some point A is there, A is positive, and some point minus A is there. The distance of origin from this point A and distance of origin to this point minus A, both these distances, they are equal to A. So when we are talking about mod of X is less than equal to A and A is positive, it means we are talking about all the points in this region from minus A to A. And how we are representing this region, these 2 points, these are also included. So it means this thing represents that minus A is less than equal to X is less than equal to A, or X belongs to closed interval minus A comma A. Next is mod of X is greater than equal to A is positive. Means again we consider this is the region, this is the point A, this is the point A. So we are talking about all those points whose distance from origin is greater than A. So we are talking about these regions. Now these points, these are included over here, this A point and this minus A point, these are included over here. So what these points are represented as, they are A comma infinity, it is closed at A. These points are minus infinity comma A, and it is closed at minus A. This point, it is closed at minus A. So we are saying what mod of X is greater than equal to A, for A is a positive real number, this thing represents the interval minus infinity to minus A union all the points A to infinity. This is the region we are talking about. These are the points that are included in this set. Next we have is mod of X is less than equal to A when A is negative. Now what we know is, if A is any negative number, it means we are talking about that mod of X is less than equal to, say A is equal to minus 3. And we know that modulus always gives us the positive answer. It means there is no possible value of X for which mod X is negative. So we are saying it has no solution, or X belongs to the set phi, it is the empty set. If we try to plot this situation, what we are saying, this is the point O, we are saying distance of the origin, all the points X whose distance from the origin it is negative, and we are saying distance cannot be negative, length cannot be negative. You can use distance or length word over here, or distance from the origin basically we are saying. So it cannot be negative, so it means there is no possible value of X, so we are saying X belongs to the set phi. Next is mod of X is greater than equal to 0 and A is negative. So we are saying, we are considering again, this is the origin over here, there is a point A which is negative. We are saying A is equal to, say, minus 3, and we are saying that the length should be greater than equal to minus 3. It means what are the possible values of X that we have? If we are saying A is equal to minus 3, we are saying mod of X should be greater than equal to minus 3. It means that this all those points whose distance is greater than equal to -3. So the first point we are saying it is, if we are writing it is greater than equal to -3, it means it is greater than equal to 0. This thing is also true. It means mod of x is greater than equal to 0. So we are talking about all those points whose distance from the origin is greater than equal to 0. So the point whose distance from the region is equal to 0 is this point 0, and the points whose distance from the origin is greater than 0, it is all the points on both sides of this. So we are saying it is the complete number line we are talking about. This is the complete number line we are talking about, and complete number line means that x belongs to minus infinity to infinity, or we are writing x belongs to R. Next is a is less than equal to mod x is less than equal to b, where a and b are positive numbers. It means we are talking about all those real number x whose distance from the origin is between the two numbers a and b. So if we mark this point as O, suppose this point we are saying this is a, this point it is minus a, this point is b, this is the point minus b. So distance of O from a and minus a, this distance we are saying it is a, this distance we are saying it is a. Next, this distance to b it is b, and this distance to minus b it is b. So we are interested in all those points. How we can write this term is, we are saying that the distance of the point x from the origin, what this thing means is distance of x from origin should be greater than a and less than b. It means we are interested in all those points whose distance from the region is greater than a and less than b. So these are the points we are talking about. These are the points we are talking about. And how we represent these points, we are saying x belongs to what this interval represents. It is a to b, a and b, these are included over here. Union, we are talking about these points over here. These are the points minus b to minus a. This thing is important to note over here, that we are not writing it in the form minus a to minus b. This thing generally students commit the mistake. This is wrong, because if a is greater than b, then we have minus b is greater than minus a. This thing you should remember, that this way of writing these intervals, it is wrong. This is the correct way to write, because minus b occurs first on the number line and we are moving towards the right hand side, we are moving towards the region. This minus b occurs first and then it is minus a. So this interval is minus b comma a, and this interval we are talking about, this is a comma b. So we are saying that whenever we have a is less than equal to mod x is less than equal to b, it means minus b is less than equal to x is less than equal to a, or a is less than equal to x is less than equal to b, and this thing is represented over here that x belongs to minus b comma a to a comma b. The next function we have, it is signum function, and it is denoted by sgn of x, and it is defined like this is the definition. We are saying y is equal to signum of x, that is equal to, this is the definition of the function. We are saying if x is not equal to 0, then the value it gives us is in this form, and if x is equal to 0, the value it gives us in this form. Now this portion we are talking about, when x is not equal to 0, we are saying if x is not equal to 0, then two cases arise. One is either x is greater than 0 or x is less than 0. In the first case, when x is greater than 0, the definition says sgn of x, that is equal to mod x over x, or you can write x over mod x. So what is the value over here? what is the value over here? We are saying when x is greater than 0, this mod x is equal to x divided by x. Answer we are getting it is equal to 1. This thing is shown over here, that if x is greater than 0, the answer we are obtaining equal to 1. This x is equal to 0 case, this we have already seen over here, that answer we are obtaining it is 0. And now the third we are talking about, it is x is less than 0, then SGN of x, that is equal to mod x over x. The answer we obtain, what is mod x when x is less than 0? The value of mod x is equal to x if x is greater than equal to 0, and it is minus x if x is less than 0. So the answer we get it is minus x over x, that is equal to minus 1. This is the case we are talking about. So signum function, it is also defined like, it is if x is greater than 0, the answer is 1. If x is less than 0, the answer is minus 1. And if x is equal to 0, the answer is 0. So if we plot this function, we are saying for x is equal to 0, the answer is 0. For all x greater than 0, the answer is equal to, this is y is equal to 1 value we are talking about. So for any, if we take x is equal to 1, 2, 3, the value of y we have, that is equal to 1. And third part we have is when x is negative, minus 1, minus 2, minus 3. In each of these cases, the value of y is equal to minus 1. So what is the domain of this function? We are saying it is defined for every value of x. So the domain of this function, it is R. And what is the range of this function? Range of this function means there are only 3 possible values it can attain. So the range of this function we get, it is minus 1, 0 and 1. That is, this function can attain only 3 values. The next, greatest integer function or the step function. So the definition for greatest integer function, it is denoted in this way. This bracket we are using. This is greatest integer function of x. It indicates the integral part of x which is nearest and smaller to x. The definition will be more clear to you with the help of the example. So we are saying, when we are talking about greatest integer function of, say, the value we are calculating, it is 2.3202. So we are saying this is the greatest integer less than equal to 2.3202. So we are saying, first of all, we are listing the integers less than equal to this. So the integers less than equal to this number, they are 2, 1, 0, minus 1, minus 2 and so on. This is the set of integers less than equal to this number. And what is greatest of all these integers? It is equal to 2. So we are saying the greatest integer value of this number, it is 2. Next, if we are talking about the number 0.23, the greatest integer of this, so we are listing, we are talking about the greatest of all the numbers, all the integers which are less than this. So what are the integers less than this? It is 0, minus 1, minus 2 and so on. And greatest of all these values, it is 0. So this is the answer we are getting over here, that the greatest integer of this number, it is 0. Next we are saying the greatest integer of 5, it is greatest integer function of for 5, it is 5, because all the integers which is less than equal to 5, we are talking about, we have to find the greatest of the values. It is 5, 4, 3, so on. 5 is included over here because we are talking about less than equal to. This is important over here. We are talking about less than or equal to this integer. So 5 is equal to this, and the greatest of all these values, this is equal to 5. Now the next example we are talking about, it is minus 8.0725. So if we draw the number line over here, We are saying this is 0, 1, 2, 3, 4, 5, 6, 7, 8. This number, this will lie somewhere over here. Minus these are negative numbers we are talking about. It is minus 8, minus 7, minus 6, minus 5, minus 4, minus 3, minus 2 and minus 1. This is negative number. It is lying somewhere over here. So what are the integers? We are talking about the greatest of the values of the integers which are less than this. So the integers that are less than this, they are minus 9, then minus 10, minus 11 and so on, and greatest of all these values, it is equal to 9. So if we are writing it in this form over here, that n is less than equal to x is less than equal to n plus 1, where n is an integer, then the greatest integer value of x is equal to n. This formula, it is more clear to you with this value. So we are saying how this function is defined. It is if 0 is less than equal to x is less than equal to 1. If the value of x, we are saying, this is the definition we are talking about. You can write it in this form, that it is continuing in this way on both the sides. So we are saying if the value of x is lying between 0 and 1, and it is equality sign over here. So for all these numbers, we are talking about the greatest of the numbers. What are the integers? We are talking about it is 0, minus 1, minus 2 and so on. And the greatest of all these values is equal to 0. Next we are saying if we are considering x to be between 1 and 2 and this 1 is included over here, then we are saying the greatest integer value we have, it is 1. If we are talking about the number say minus 1 to 0, in this case this minus 1 is included over here. So the answer for the greatest integer function we are getting, it is minus 1. You can try to find these values over here. So what we get is, if we plot the graph for this function, we are saying when x is lying between 0 and 1 and 0 is included, we are talking about 0 is included and it is up to this point 1, the value of the function we have, it is equal to 0. Next, when we are talking about the numbers x between 1 and 2, 1 is included. We are talking about the numbers when 1 is included. Look at this dot over here, it is the solid dot. It means 1 is included at this point, 2 is not included over here, and the answer we are obtaining, that is equal to, this is the value of greatest integer of x we are saying, we are getting in this form. So if we plot all these points, we are getting between 0 and 1, the answer we are getting, it is 0. For all numbers between 1 and 2, we are getting the answer, it is 1. For all numbers between 2 and 3, including 2, we are getting the answer, it is 2. Similarly, for negative, we have these two answers over here. So we can see that these are just like the steps we are talking about, that if we are moving the steps over here. So this function is also called the step function. Now, from the graph, it is clear that this function is defined for all values of x. So the domain of this function is R, and the answers we are obtaining, they are the integer values, that is 0, 1, 2 or plus minus 1, plus minus 2. These are the answers we are obtaining for these from this function. So we are saying the range set of this function, that is equal to z. The range of this function, it is z, that is set of integers. The next function we have, it is fractional part function. So we are saying it is indicated like this, that these brackets are used over here. This is representing the fractional part of x. So we are saying if x is any number and we are writing it is I plus f, where I is the greatest integer function or integral part of this, and f we are saying that is equal to the, this f we are talking about, this is the fractional part that is remaining. So if suppose I am talking about what is the fractional part of 1.32, so we are saying the number x we have, it is 1.32. We can write this is equal to 1.32 plus the value, it is not 1.32, it is 1 plus 0.32, where 1 is, if we are talking about the greatest integer function of 1.32, that is equal to 1. So this value 1 is from here, and this remaining part that we have, it is actually the value of the fractional part of this function. So if we plot the graph for this function, or if we plot the values of this function, so we are saying if the value of x is lying between 0 and 1, so the value of the fractional part, it is x. Suppose for example we are saying it is 0.5, and we are talking about fractional part, it is 0 plus 0.5. the answer we obtain for the fractional part, it is x itself. Now the next value, if we are talking about, say it is 1.3, the fractional part of 1.3, it is 1 plus 0.3. the answer we obtain, that is equal to 0.3. so the answer for the fractional part that we have, it is equal to x minus 1, that is 1.3 minus 1, that is equal to 0.3. this 1 we are saying, this is basically the when we are talking about the numbers over here, we are saying the greatest integer function for these numbers, it is 1. The greatest integer for these numbers, it is 2. The greatest integer for these numbers, it is minus 1. And greatest integer for these numbers, it is minus 2. So we are getting the answers in the form. We are saying, suppose I am talking about these values over here. The formula we have is y is equal to the greatest integer of x, that is equal to x minus greatest integer of x. So when we are talking about that, x lies between these two values. The greatest integer value of x, it is minus 2. So the answer we are getting, it is x plus 2. The formula we are getting, it is x plus 2. So now if we plot these functions, we are saying what we are going to plot is, this first is y is equal to x. This second is basically y is equal to x minus 1. This third is y is equal to x minus 2. This is y is equal to x plus 1. The regions we have is, this is y is equal to x. This is when x belongs to 0 to 1. Then next, when x belongs to 1 to 2. This is next, it is when x belongs to, this terms we are talking about, it is when x belongs to 2 to 3. This is when x belongs to minus 1 to 0. So if we plot all these lines between 0 and 1, we have plotted the line y is equal to x. This is the line y is equal to x between 0 to 1. Next line we have to plot between 1 to 2, we have plotted y is equal to x minus 1. This is the line. What we are saying is, if we have to plot the line y is equal to x minus 1, it is this line over here. This is the line, but we want to plot this line between 1 to 2. So this point we are saying it is 1, this point it is 2. So we are not interested in this portion of the line, we are remaining with this part only, and this is represented over here, that this 2 is excluded. Similarly, we are getting these other portions over here. So this is the graph of the function fractional part of any function. Talk about the domain and range of this function, then the domain of this function, the domain is that any real number we can substitute in these values. And if we are talking about the range of this function, the range of this function means we are talking about the values of the y, they all lie between the minimum value of y that we can have, it is equal to 0. The minimum value we have, it is equal to 0, but it cannot attain the value 1. So we are saying the maximum value we are talking about, it is up to 1. So this interval, it is open from this side. So range of this function, it is 0 to 1 with the bracket, it is closed from the side 0 and open from the side 1. So this is the range of this function. Next we are talking about the least integer function. So when we are talking about the greatest integer function, we are saying it is the greatest of all integers which are less than equal to x. When we are talking about the least integer function, it is we are saying the smallest or least value out of the integers which are greater than equal to x. So if we have to calculate the least integer value, say of 2.3203, so we are saying it is smallest of the values, all the integers which are greater than equal to this, so they are 3, 4, 5 and so on, and smallest of all these it is 3. Suppose we are talking about the value minus 8.0725, the least, it is smallest of all the integers which are greater than equal to this number, so they are minus 8, minus 9 and so on. The answer we are obtaining it is minus 8. Suppose I am talking about the greatest integer of say minus 1, it is smallest of all the values, that is minus 1, 0, 1, 2, and smallest of all these values, that is equal to minus 1. Now we are saying if n is less than x is less than equal to n plus 1, suppose we are talking about any number, say it is 3.1, so we are saying it is greater than 3 and less than equal to 4. So we are saying the least integer value of x, that is equal to least integer of 3.1, that is equal to this number 4. This thing is mentioned over here, that for n is less than x is less than n plus 1, the least integer value we have it is equal to n plus 1. So we have listed some values over here, that if the value of x lies between 0 and 1, 0 is included, then the answer we have it is 0. So this thing is plotted over here in this graph. Next we are saying if the value of x lies between 0 and 1, the answer we obtain it is 1. This is the second part we are talking about, that if the values lie between 0 and 1 with 1 included and 0 is excluded, the answer we are obtaining it is 1. Next, if the values of x they lie between 1 and 2, the values of x they lie between 1 and 2, the answer we obtain it is 2. Similarly, if the values of x they lie between 2 and 3, the answer we are obtaining it is 3. And if the value of x is lying between minus 1 and minus 2, the answer we are obtaining in this case it is equal to minus 1. So this is the graphical representation of this function. Now if we talk about the domain of this function, the domain of this function it is R, that is we can calculate the least integer function for any real number R, and the range of this function it is equal to Z. That is the possible answer we have, it is they are the integers. So this function it is also called the ceiling function. The greatest integer function it is called the floor function, and this function it is called the ceiling of x. Next we have listed some properties of the greatest integer functions. The first property we have listed over here, it is that greatest integer of x is less than equal to x is less than greatest integer of x plus 1. Now we know that if any number is given to us, x we are talking about, we can write it is equal to the greatest integer of x plus the fractional part of that number. Now from this what we get is that greatest integer of x, that is equal to x minus the fractional part. So this thing gives us that greatest integer of x is always less than equal to x. The fractional part it can be 0, or the value it lies between 0 and 1. So we are saying greatest integer of x is always less than equal to x. Or we can look at this condition using the value that if n is any integer and n is less than equal to x, we are saying n is less than equal to x is less than equal to n plus 1, or we are saying it is lesser than n plus 1, then we have the greatest integer of x that is equal to n. So we can just consider it like this, that greatest integer of x is equal to n, and this inequality given over here, these are representing the same thing. Now we have greatest integer of x is less than equal to x is less than greatest integer of x plus 1. Now look at this condition over here. So what we get is that x minus 1 is less than greatest integer of x, and this is less than x. It is less than equal to x. This part we have already seen. Next we have is I is less than equal to x is less than equal to I plus 1. Then greatest integer of x is equal to I, where I belongs to z. This property we have already seen during the definition of the greatest integer function. Next we have is greatest integer of x is equal to greatest integer of x. We are saying when we will calculate greatest integer of x, this will be some number n belongs to z, and the greatest integer of this function, that will be equal to n, the integer we are talking about. So we are saying that the greatest integer of x, that is equal to greatest integer of x. Next is greatest integer of x plus greatest integer of minus x. Suppose we are considering some example over here. Suppose x we are taking, it is 1.3. So what is greatest integer of 1.3? That is equal to 1. And what is greatest integer of minus 1.3? That will be equal to minus 2. So sum of both these values will be, if we add both these values, we are writing greatest integer of 1.3 plus greatest integer of minus 1.3, that is equal to minus 1. So we are saying if x is not an integer, then the sum of these two values, it is minus 1. Next, if both of these are integers, we are talking about greatest integer of 1 plus greatest integer of minus 1. The answer we are getting, it is 1 minus 1 is equal to 0. So we are saying if x is an integer, then sum of both these values, it is equal to 0. So from this result, we are saying that the greatest integer of minus x, that is equal to minus greatest integer of x, or minus 1 minus greatest integer of x. This is when x belongs to z, and this is when x does not belong to z. Now look at this case over here. When x belongs to z, greatest integer of x is x. So we are writing it is equal to minus x. So we are getting this result that greatest integer of minus x, it is equal to minus x if x belongs to z, and it is minus 1 minus greatest integer of x if x does not belong to z. Now from the previous result, we have seen that greatest integer of minus x, that is equal to minus x if x belongs to z, and it is equal to minus 1 minus greatest integer of x if x does not belong to z. Now if we subtract this value of minus greatest integer of minus x from the greatest integer of x, we will get this is greatest integer of x minus this value, and greatest integer of x minus this value. Now what is greatest integer of x when x belongs to z? We are saying when x belongs to z, greatest integer of x is equal to x. So this numerator part, this becomes 2x, and this denominator part, it is greatest integer of x plus 1 plus greatest integer of x. So this total value, this will become 2 times greatest integer of x plus 1. So this is the formula that we are getting from this. Next is greatest integer of x plus minus n, that is equal to greatest integer of x plus minus n. Now next we have to prove is that this greatest integer of this whole function x plus minus n, that is equal to the greatest integer of x plus minus this value n, where n belongs to z. So suppose we are saying this number x we are talking about, it has some value or the greatest integer of x plus some fractional part of x. Now this number, suppose this is the number m we are saying, and m belongs to z. So if we substitute this in this formula, we are getting m plus integral part of x plus minus n. This is equal to m plus minus n plus the fractional part of the number x. And what is the answer for this? We know that the answer for this will be m plus minus n plus this integral part will be removed, and this is what we are saying, that this is equal to the integral part of x plus minus n. It is not integral part, it is the greatest integer function of x plus minus n. Whatever we have added or subtracted, we will get that answer. So what this thing means is, if we are calculating the greatest integer function of say 1.7 plus 3, so we are saying the answer we will obtain, it is the greatest integer function of 1.7 plus 3. So answer we are getting, it is equal to 1 plus 3, that is equal to 4. Next we have is, if greatest integer of x is greater than equal to n, so this is implied and implied by, this implies and implied by x is greater than equal to n. So we are talking about two cases over here, that if greatest integer of a function is greater than equal to n, then we are saying that x is greater than equal to n. It means that the number is greater than equal to n. And if any number is greater than equal to n, then its greatest integer part, it is greater than equal to n. So these things, these are clear from the definition. We are not moving towards the proof of these results. We are just understanding these results, and this particular result, this is clear from the definition of the greatest integer function. Now the next part we are saying, it is, if greatest integer of x is greater than n, then this thing implies that x is greater than equal to n plus 1. And if greatest integer of x is greater than n, then this the converse part we are talking about, that if x is greater than n plus 1, then this implies us that greater integer function of x, it is greater than n. Similarly, we have these next two properties, that if greatest integer of x is less than equal to n, then this is implied by, this implies and implied by x is less than n plus 1. And next we have is, if greatest integer of x is less than n, then if and only if x is less than n. So these are some properties for greatest integer functions. These are some basic properties or inequalities related to greatest integer functions. Now the next property we have is that greatest integer of x, that is equal to greatest integer of x by 2 plus greatest integer of x plus 1 by 2. Now the next property we have is that the greatest integer of x, this is equal to x by 2 plus greatest integer of x plus 1 by 2. So we are having two cases. One, either x is an integer. So we are saying, suppose x by 2 we are talking about, say this is equal to an integer and that is equal to n. So what we get is that x is equal to 2n. Now this term we can also write, it is x by 2 greatest integer plus x by 2 plus 1 by 2 greatest integer of this value. Now we are saying the value of x by 2 we have, it is n, it is an integer. So the value of the greatest integer of x, it is equal to 2n, that is also an integer. The value of this term will be equal to n, and value of this term is also equal to n, and sum of both these values, this is equal to 2n. Now second case we are saying, suppose x by 2 is not an integer. So we are considering that x by 2 that is equal to greatest integer of x by 2 plus some fractional part. So this is equal to x by 2, we are saying the integral part of this, it is n plus f. This is the value of x by 2 we are considering, that it is not an integer, it has some fractional part over here. So these values of f we have, either the value of f can be between 0 is less than f is less than equal to 0.5, or the value of f can be 0.5 is less than f is less than 1, because the case f is equal to 0, this thing we have already studied when we are saying that x by 2 is an integer. Now from this result, we are talking about this result over here, what we get is that the value of x that we have, that is equal to 2n plus 2f. This is the value of x that we obtain from this part. So if we take the greatest integer of x, we are having the value, it is 2n plus 2f greatest integer. Now what is the value of 2f? We are saying if 0 is less than f is less than 0.5, we are talking about this first condition over here. So we will get 0 is less than 2f is less than equal to 1. And in this case, the value of greatest integer of x, that is equal to 2n. We should remove the equality sign from here, and we should put this equality sign over. We are removing this equality sign from here. Second part, we are saying if 0.5 is less than equal to f is less than 1, then what we will have, the value of 2f, that will be, we are saying 1 is less than equal to 2f is less than 2. So the value of greatest integer function x that we will have, it is equal to 2n plus 1. Why? Because now the fractional part of this number over here, we are saying 2f, it is greater than 1. So the answer we will obtain, that is equal to 2n plus 1. Now we come to the next part over here. We are saying the number we have, next number we have, it is x by 2 fractional part. Now again, the answer for this number, that will be equal to n. The answer for this number, that will be equal to n, because we have considered that the value we have over here, that is equal to the fractional part of this, means fractional part of n plus f, and this f always lies between 0 and 1. So the answer we are obtaining, it is equal to n. And what is fractional part of x by 2 plus 1 by 2? Again, two cases are there. We are saying this is equal to the fractional part of n plus f plus 1 by 2 when f is between 0 and 0.5, and it is n plus f plus 1 by 2 when 0.5 is less than f is less than 1. Now when f is between 0 and 0.5 and we add 1 by 2 to it, the final answer that we will get, it is n. When f is between 0.5 and 1 and we add 1 by 2 to it, the total value will become 1 is less than f is less than 2. So when we substitute this value over here, it is less than equal to over here. So we get the answer is n plus 1. So if we add both these values, we are talking about these two values over here. One is the value of x by, greatest integer of x by 2 is always n, and greatest integer of x by 2 plus 1 by 2, it is equal to n or n plus 1. So if we add both these values, we will get the answer in this form, that the greatest integer of x we have obtained, it is equal to 2n when f is between 0 and 0.5, and this value is equal to 2n plus 1. This is equal to 2n, this is equal to 2n plus 1 when the value of f, it lies between 0.5 and 1. So we have proved this result. So you must remember this result, that greatest integer of x, when we are saying, that is equal to greatest integer of x by 2 plus greatest integer of x plus 1 by 2. Next we have is greatest integer of n plus 1 by 2 plus n plus 2 by 4. So this term we are talking about, this term we are saying, you can write it in the form, it is greatest integer of n plus 1 by 2 plus this n plus 1 by 2, we can write it in this form, that it is n by 2 plus 1 by 2 plus n by 4 plus 1 by 2. Next it is n by 8 plus 1 by 2 and so on. So if we look at this previous formula we have proved, we have the greatest integer of n, that is equal to greatest integer of n by 2 plus greatest integer of n plus 1 by 2. This is equal to greatest integer of n by 2 plus n by 2 plus 1, and this value is equal to n. So this thing gives us that n is equal to, it is n by 2 plus 1 by 2 plus greatest integer of n by 2. Now if we use the same formula for the value n by 2, greatest integer of n by 2, that will be equal to greatest integer of n by 4 plus n by 2 plus 1 by 2. So the answer you will get, it is n by 4 plus greatest integer of n by 4 plus 1 by 2. So in place of this n by 2, we are writing it is equal to n by 4 plus 1 by 2 plus n by 4. Similarly, in place of this n by 4, we can write it is n by 8 plus 1 by 2 plus n by 8. Next value we get, it is upon n by 8. Now again writing this n by 8, we will get the next term, and we will continue like this, and we will obtain this equality, that is the greatest integer of n plus 1 by 2, that is equal to n plus 2 by 4 plus n plus 4 by 8 and so on, and this is equal to the value n that we have. Next we have this property, we are saying the greatest integer of x plus y, that is less than equal to greatest integer of x plus y is less than equal to greatest integer of x plus greatest integer of y plus 1. So if we take x and y, they are integers, then we know that greatest integer of x plus y, that is equal to greatest integer of x plus greatest integer of y. So we have to prove for the case when x or y, they are not integers, we are saying x or y is not an integer. So we can consider the different cases whether x is positive, y is negative, and for each different case we can prove that these inequalities will hold. So you must remember this inequality, that greatest integer of x plus greatest integer of y, it is always less than equal to greatest integer of x plus y, and this is less than equal to greatest integer of x plus greatest integer of y plus 1. Similarly, this result we have, it is greatest integer of x plus greatest integer of x plus 1 by n plus greatest integer of x plus 2 by n, so on up to greatest integer of x plus n minus 1 by n, that is equal to nx. And you can prove this result by using the principle of mathematical induction that we will study in our next chapters. This result you should remember, and we are going to prove this result in our next chapter. Next we have some problems based upon the formulas that we have studied. So first we have is, if x and this x, they represent the fractional and the integral parts of x respectively, then find the value of this term. The term that is given to us is, it is greatest integer of x plus, this is the basically the fractional part of x, plus sigma r is equal to 1 to 2000 x plus r, it is the fractional part of this term, over 2000, where x is any number that is given to us. So to calculate this value, we are talking about this term over here. So what we can see from this term is, if we look at these terms over here, this term I'm talking about, the greatest integer of x plus r, the fractional part of x plus r. If we are saying r is an integer, because the values of r, they are 1, 2, 3, 4, so on up to 2000. So if this r are these integer values or natural numbers, we are in this case we are saying, so this is equal to the fractional part of x. It is clear to us. If we are talking about 1.3 plus any number r is there, and we are talking about the fractional part of this number, we are adding some r to it, so that is equal to the fractional part of 1 by 3. Suppose this number is minus 1.3, even then the answer will be fractional part of minus 1.3. So we are saying this numerator, in place of this we can write it as fractional part of x. In place of fractional part of x plus r, we can write it as fractional part of x. So our formula will become, it is x plus fractional part of x over 2000. Now we are saying this r is equal to 1 to 2000. There is no term r over here, so this sum, it is immaterial, and basically we are adding these whole terms 2000 times. It is just like x by 2000 plus x by 2000, and we are adding these terms 2000 times. So we are writing it is 2000 into this 2000 and 2000 gets cancelled, so we are left with this greatest integer of x plus fractional part of x, and that is equal to x. So the value of this term is equal to x. Now next we have to solve this equality. That is, we have to find the value of x for which this is true. We know the formula that x is equal to greatest integer of x plus the fractional part of x. So we start with this, in this equality we are saying 4 times fractional part of x. In place of x we are using this formula, so we get it is greatest integer of x plus fractional part of x plus greatest integer of x. So this is equal to 2 times greatest integer of x plus fractional part of x. So we get fractional part of x, that is equal to 2 times greatest integer of x upon 3. This is the value we are getting, that fractional part of x, it is equal to 2 times greatest integer of x by 3. So from this term, what we know is that the fractional part, the value of fractional part of any number, it lies between 0 and 1, where 0 is included. So we can substitute this value over here. So we are writing it is 0 is less than equal to 2 times the greatest integer of x over 3 is less than 1. So it means 0 is less than equal to greatest integer of x is less than 3 by 2. So what this thing gives us, that the greatest integer of x, it lies between, it can have the values either, greatest integer of x, it can either have value 1 or 0. Why? Because it lies between 0 and 1.5, and greatest integer of x, it has only the integral values. The 0 is included over here, so we are saying only two possible values, they are 0 and 1 for greatest integer of x. So if we substitute the value of greatest integer of x equal to 1, the value of the fractional part, we are saying we have this formula over here, the value of the fractional part we will have, that is equal to 2 by 3. And if we put the value of greatest integer is 0, then the value of fractional part of x, that we will have it equal to 0. So for the first case, we are saying the number x will be, the formula for the value of x, it is greatest integer of x plus fractional part of x. So for the first case we have 1 plus 2 by 3, that is equal to 5 by 3. And for the second case, this value x, it will have fractional part of x. So the answer we will get, that is equal to 0. So we are saying there are two possible values of x. It is 0 and 5 by 3. Next we have to prove the result that greatest integer of x plus greatest integer of y is less than equal to greatest integer of x plus y. This property we have already studied previously. So we start where it is given that x is equal to this and y is equal to this, and these notations you already know. So we are saying x plus y, that will be equal to greatest integer of x plus greatest integer of y plus fractional part of x plus fractional part of y. So if we take the fractional part or greatest integer function, we apply the greatest integer function on both sides, the answer we will obtain, that is equal to greatest integer of x plus greatest integer of y plus greatest integer of x plus y. We are saying this is the fractional part we are talking about of the two numbers. So this term, it is greater than equal to 0. So this thing implies us that the greatest integer of x plus y is greater than equal to greatest integer of x plus greatest integer of y. Next we have to find the solution of mod of greatest integer of x minus 2x is equal to 4. So again we are assuming that x is equal to I plus f, where I is the integral part. You can write it as greatest integer of x plus the fractional part of x, or you can write it as I plus f. So this equation will become mod of, in place of greatest integer of x, we are writing it is greatest integer of I plus f minus 2 times I plus f, and that is equal to 4. So this thing implies us that mod of I minus 2i minus 2f is equal to 4, because when we are talking about the greatest integer of I plus f, the value that is equal to I. So this thing implies us that the greatest integer of I plus 2f, why it is I plus 2f, in place of this first we are writing it is minus I minus 2f, that is equal to 4. This thing implies us greatest integer of I plus 2f is equal to 4, and this thing is possible only if the value of f we have, that is equal to 1 by 2 or 0, because we are saying this I is already the integral part and we are adding some 2f to it, and f is some, we are saying either it is a fraction or it can be 0. The values of f that we can have, it is 0 is less than equal to f is less than 1. So we are saying what are the possible values of f for which I plus f, this is a equal to 4, that is it is an integral value. For this to be integral value, it means 2f should be integral value. 2f should have an integral value. Now 2f will have integral value only if either f is equal to 1 by 2, then 2f will be equal to 1, or f is equal to 0. In that case 2f will be equal to 0. So we are saying we have two values of f, either f is equal to 1 by 2 or f is equal to 0. Now in the first case we are saying if f is equal to 1 by 2, then mod of I plus 1 is equal to 4. This thing we have substituted over here, this value of f we have substituted in this equation. So we get that the value of I we have, that is equal to 3 or minus 5 for f is equal to 1 by 2. Similarly, if we put f is equal to 0, we will get the value of I, it is plus minus 4. So the possible solutions there, it is plus minus 4 over here. Next it is f is 1 by 2 corresponding to these I. So the answers we have 3 plus 1 by 2 or minus 5 plus 1 by 2. So the answer we have, it is 7 by 2, and this is equal to minus 9 by 2. So we are saying these four values, these are the possible values of x that we can